Hello all, welcome back to my devlog where I make a game engine and try to make a game in it. I continued with the art pass in March and April, specifically around upgrades to the graphics system. The first upgrade was adding arbitrary quad rendering to the engine. Up to now, the engine could only render images as is. No resizing, no rotating, just the image with an offset. Arbitrary quad rendering lets me render images in any orientation by moving the four corners of the image independently. The algorithm that I use is inspired by the rendering backend used in the Sega Saturn. I step along the left and right sides of the image in transform space, and using those points, the image scanline is scaled and drawn as a line between them. The Sega Saturn has overdraw issues, meaning that a pixel can be drawn to twice if the lines get too close to each other. I fixed this by drawing the quad to a temporary buffer without blending, and then drawing the temporary buffer to the screen with blending so that the blend command only gets called once. Now the game was not created with this plan to be a feature, so it probably will not be used much, but it's nice to have if I want to use it. The second upgrade was to the OpenGL version. In the beginning of MateBit, I used OpenGL version 1.1 because I only needed it to draw an image to the screen. And for a long time, 1.1 was the highest version of OpenGL pre-installed on Windows PCs. Recently though, I started using a different graphics driver on my home computer, and ended up seeing this. This does not happen on my 3D rendering test that uses OpenGL 3.3, so I converted MateBit to use that version. While I was at it, I wanted to make custom wrappers to make drawing on the GPU easier. Drawing on the GPU can be verbose at best. I've heard that newer renderers like Vulkan need over 300 lines of code to draw a simple triangle. But when you break it down, there are only a handful of object types that are actually used in GPU drawing. So I created a set of primitives that can slot into each other easily to draw, instead of endless lines of bloat code. For example, to draw this model, the vertices used to draw the mesh are stored in arrays or buffers. The textures are stored in, well, textures. They're actually still called textures under the hood. The code to map vertices onto the screen and to shade the model are compiled into shaders. And then everything is shoved into a program that wires everything together automatically. Vertices are given to the vertex shader, the outputs of that and the textures are given to the pixel shader, which draws the final image onto the screen. Simple, right? Much better than the alternative. The last upgrade is not that big of one. DrawBlock, which is the function that's been responsible for all the drawing in MateBit up to this point, was renamed to DrawSprite, to use industry standard terminology. All references to block in the code were also renamed to Sprite. Other than adding more art, the next upgrade planned is to the Epic Online Services networking system. Maybe actually finishing the system, and removing some of the few points that were hard-coded. But that does it for this video. Thank you for watching and see you all next time.